Now, this is my lecture number 20.2. Now, in this, I'll discuss conversion of analog signal to digital signal. Now, continuous variable signal is known as an analog signal, where value voltage, and this is a real time. So, voltage varies continuously with a real time. So, that is known as a digital analog signal, and having a discrete value is known as a digital signal. So here we want to convert analog into digital. So what is the process now? Voltage is varying continuously with respect of time. So what we do, we take voltage at particular time, and we will note down those voltages. What was actual voltage? Let us say here my range is between 0 and 5. So what was a particular voltage at particular time? So that all voltages we memorize or put in memory. And if we suppose I have taken voltages at this point, this way I have sampled this signal, and I have taken voltages at different intervals. So these are the voltages which I have memorized in memory. And if I draw on a graph again, so these were the voltages which were taken at a different time interval. So if I connect this, so this will give me original waveform. But here one drawback is this: if I join these voltages, so you will get something like a graph like this, which is little different from original. Here this is smoothly smooth curve is there. Here point to point connection is there. So this, if I exaggerate or enlarge this, so you have a graph like this and not like this. So there is some difference between original and recorded waveform. So if I and signal is varying in this way, and if I take sample at these intervals, and if I again draw those points and connect, so I will have a graph like this, which is little different from original. This should not be there. So it should be as real as original one. So that means something should be done so that I can achieve that thing. Now in sampling process, now this is sampling I take on real time basis. Okay, at particular time what was value of this, and at particular time what was value of this. This process is known as a sampling. Now one scientist was there, Nyquist. He said, if my sampling frequency is double than the frequency of a variable signal, then I can achieve the results which will be very near to the original one. This is Nyquist theorem. Sampling frequency should be double than the frequency of the varying signal. This is Nyquist theorem. So which is true also. Now here if I exaggerate this, here I am taking let us say this is signal. So one point here, this is T and this is V. So I take sample here, and if I take sample here at T2, this is T1, T2 and T3. Now at T1 whatever was the voltage is noted down, and this is memorized in memory block. Again at T2 what was voltage is again goes to memory block. So at every time interval this value is memorized in memory block, and when again this is brought back and draw graph, this will give you the original one. Now here if I take one voltage here and one voltage here, so this is missed, if I redraw this, so I will have a graph like this and not like this. Just to achieve what I should do, I should increase the sampling frequency. So if I take one sample here, then I can have a better result. But again here graph is like this and not like this. So again if I take one sample here, one here, then I will have a better signal or a shape of a graph like this. So you increase the sampling frequency so that no detail is left. So that means if my sampling frequency is very high so that no detail is left, I take sample at such a small interval of time so that no detail is left. If I go this way, then again if I redraw from those values, digital values, if I redraw this graph, I can have a better result with a higher clock pulse. So this process is known as a sampling, and in sampling, the frequency of sampling should be as high as possible to get the original results or results near to the original. So this is known as a sampling, and this is Nyquist's theorem is a sampling theorem which says the sampling frequency should be double than the frequency of the varying signal. But practically nowadays we have advanced technology where clock pulse is in our phone or in our processors, clock pulse is very high, maybe 1 megahertz or 1 GB or more than that, 1 gigahertz. So sampling frequency is very high. That is why we are able to get the results very near to the original results. So this was sampling process.